You've chosen this video because you want to learn how to solve quadratic equations with imaginary solutions. So for this, we're going to have to remember the definition of the square root of -1 is your imaginary unit I. And whenever you have the square root of -1, you always have to change it to I. I'm going to walk you through 3 examples where we take the square root of both sides, and then the last 2 examples will actually use a quadratic formula. Here's our first example. Now, since we don't have an x term, we only have an x squared term and a constant, we can use solving by taking the square root of both sides. We'll subtract 25 on both sides, and then we can take the square root of both sides. Now, just to remember what we're doing here, I just want to show you really quickly if we had just x squared minus 25 equals 0. And so we added 25 to both sides, and we took the square root of both sides. You can see how similar this is. This one just doesn't have the negative. So we're going to do pretty much the exact same thing that we do when it's a positive. The only difference that it's going to have is it's going to have the square root of -1, which is going to be an I in our solution. So it's going to be very helpful to just look at this and remember how we do this and apply it to this problem. So when you take the square root of both sides, you'll remember that you always get a plus or a minus solution. The square root of 25 is 5. Now that means that we have 2 solutions. We have positive 5 and we have -5. Now most of the time you can just write your solution as plus or minus 5. Now quickly, where this actually comes from, this plus or minus, is a step that we usually leave out right here. When we have x squared equals 25 and we take the square root of both sides, technically the square root of x squared is the absolute value of x, and the square root of 25 is 5. And that's why x would equal plus or minus 5, because the absolute value of 5 is 5 and the absolute value of -5 is also 5. But again, this step is usually left out, and we usually just go straight from this to this, but I thought you would like to see where that actually comes from. Now, we know that since we're squaring the number, it could be positive or negative, because positive 5 squared is 25 and -5 squared is also 25. We could have also solved it by factoring this one, and so we would see that we would have our 2 solutions as well. So many options. Let's go back to this one now. So we're going to solve it just the same way that we solved this one, where we're going to say x equals plus or minus 5, but since we have the square root of -1, it's going to be plus or minus 5i, and that's going to be our solution, a positive 5i and a -5i. Now, something really handy about imaginary solutions is that they always come in pairs. So you'll remember that it's plus or minus. Here's our next example. Now, again, since we don't have an x term, we can solve by taking square roots of both sides. We'll subtract 81 on both sides, and then we'll divide both sides by 4. And then we'll take the square root of both sides. Now, when we take the square root of this right side, what this really means is that we have plus or minus, we have the square root of 81 over the square root of 4, and then we have the square root of -1 as well. So this negative, we're just going to separate that out since we know that will be I. And then whenever you have a fraction under a radical, that means that you're taking the square root of the numerator and you're taking the square root of the denominator. So since these are both perfect squares, the square root of 81 is 9, the square root of negative 1, we have to change that to I, and the square root of 4 is 2. So this is our final answer. Let's look at another example where your numerator is not a perfect square. Thank you for choosing Math with Caroline. Please give a thumbs up if you're learning, subscribe, and share this video with your friends. Here's our next example. We'll subtract 8 on both sides, then divide by 9, and then take the square root of both sides, which means that we get plus or minus. Whenever you're solving for x and you take the square root of x squared, you're going to get that plus or minus. Now we're going to do the square root of 8, and that's times the square root of negative 1 over the square root of 9. If you'll take the time to write out this step, it will probably really minimize mistakes. Now we know this is equal to I. We know the square root of 9 is equal to 3. The square root of 8, though, we need to simplify this. And if you need more help on this, I have a whole other video on simplifying radicals, simplifying square roots. And so there is a perfect square that 8 is divisible by. So we will need to simplify that. So we have plus or minus. Now 8, I'm just going to split that up in the square root of 4 times square root of 2, and then times I over 3, just to show you exactly where this is all coming from. The square root of 4 times the square root of 2 is the square root of 8, since 4 is a perfect square. The square root of negative 1 is I, the square root of 9 is 3. The square root of 4 is 2, so we're going to simplify that. Now, it's okay if you leave your answer like this, because this clearly shows that the 2 here is under the square root, but the I is not. But usually, when you look at answers in the back of the book, you'll see it written like this. And you do need to recognize that that is the exact same answer. Usually, you will have your number, and then your I, and then your radical. That just makes it easier to see what is under the radical and what's not. So anything that's not in the radical, you'll really want to put it up front here. For this next example, you can see that we do have an x term, and so we cannot take the square root of both sides. Now you also know this is not factorable, because there's no two numbers that multiply to 8 and add to 5. And so we have to use quadratic formula. The quadratic formula for a quadratic written in standard form, ax squared plus bx plus c equal to 0, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're hopefully singing the song right now. Now I do have a whole other video on quadratic formula, but these two examples are really going to focus on our imaginary solutions. So since we have our quadratic in standard form, we can see that a is equal to 1, b is equal to 5, and c is equal to 8, coming from our coefficient here, 1, 5, and positive 8, and positive 5. So we can write those down and plug those in to our formula. And so we have x equals negative b, which is negative 5, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now it's very important that you really take the time to write this out. It will really minimize errors if you don't do too much in this step. Then we can simplify everything. So we have negative 5 plus or minus the square root of 25 minus 4 times 8 is 32 over 2. Now we can subtract 25 minus 32, and you can see that that is going to be a negative number since 32 is bigger. 25 minus 32 is negative 7. So now you see this negative under the radical again, under the square root, and so you know that that is going to be an imaginary number. So we know that this is going to be negative 5 plus or minus I times the root 7 over 2, since the square root of negative 7 is equal to the square root of 7 times the square root of negative 1, and we know that the square root of negative 1 is I. So we'll put that in the front to be clear that that's not under the radical, and we cannot simplify the square root of 7, so we're just going to leave that as is. Now, if your directions specifically say to write your answer in standard form, the standard form of a complex number is a plus bi, which just means that we would want to split these apart into the real part and the imaginary part. So we're going to divide negative 5 by 2, and then we'll divide our I times square root of 7 by 2 as well, and we're just basically splitting it up into negative 5 over 2 plus or minus I root 7 over 2, and that's what x is equal to. We have two solutions. Let's do one more example where we have to simplify the radical again. For this example, we need to identify a, b, and c so that we can use a quadratic formula. So a is equal to 4, b is equal to negative 6, and c is equal to 5. And so plugging those into our quadratic formula, we have negative 6, so that becomes a positive 6. And we have negative 6 squared minus 4a times c all over 2 times a. Now it's really important to have these parentheses here. When you're squaring b, if b is negative, you need to make sure you have these parentheses because this should always come out to be a positive number. So let's simplify everything. So we have 36 minus 4 times 4 is 16 times 5 is 80. 4 times 2 is 8. So 36 minus 80, you can see that that is going to be a negative number. That is negative 44. So now we see that we have a negative under our square root, so that's going to be I. But we also have 44, which we can simplify, so we must simplify. What perfect square is 44 divisible by? 4. So let's split it up. We've got the square root of 4 times the square root of 11 times the square root of negative 1. Because 4 times 11 is 44, and 4 is a perfect square, and we know the square root of 4 is 2. So we'll simplify everything and get that 2i in front and leave our square root of 11 all over 8. Now we must actually simplify this because 6, 2, and 8 all have a common factor of 2. Now this is easiest to do if you do split it up into standard form, that a plus bi. So you take your 6 over your 8 and you do plus or minus 2i times the root 11 over 8 as well. And this ensures that when you simplify, you don't accidentally cancel something out wrong. We'll do the 6 and 8. That simplifies to what? 3 over 4, since you can divide both of them by 2. And then the 2 over 8 will simplify to what? 1 over 4, since 8 divided by 2 is 4. So now we'll write our final simplified answer, 3/4 plus or minus I times the root 11 over 4. I hope that you have learned how to solve quadratic equations with imaginary solutions. Please leave a comment. I would love to hear from you.